Hello, everyone. Welcome to Con 209. This is Getting Up and Running with Amazon EKS. My name is Mike Stefaniak. I'm a product manager on the EKS team here at AWS, and I have the pleasure of being joined today by Sudhir Adamula and Vamsi Kaluri from the Verizon team. We're going to split the presentation today into two separate parts. I'm going to start by talking about EKS in the three phases we like to think about it, as well as some tools for getting started. And then I'm going to hand it over to the Verizon team, who's going to talk about their migration from self-managed Kubernetes onto EKS, some of the challenges they faced, and the things they did to overcome those challenges. We like to think of EKS as a three-phase story. When we launched, we had the managed control plane. We then, last year's reInvent, launched some managed data plane options. And then this year at reInvent, we're starting with the management of certain operational add-ons. And we're going to talk about each of these three phases briefly here. So the managed control plane. The point of showing this picture here is we kind of want you to see that running a highly available control plane in production falls squarely in that undifferentiated heavy lifting bucket that we like to talk about at EKS. Before we launched EKS 2.5 years ago now, we heard from customers that running a control plane is not something that provides business value to them, and they want to hand that off to EKS. And that's really why EKS was born, is that running this kind of control plane in production is not easy. So with Amazon EKS, you get a managed control plane. We make it easy to get started with Kubernetes. From day one, the first focus of EKS was always a production-ready control plane that was highly available and highly scalable. You get a 99.95 SLA with EKS, and the control plane is automatically scaled. So if you get an application traffic spike and you need to add more pods or nodes to your cluster, EKS will automatically scale the control plane in order to handle that increased load. EKS is native Kubernetes. It's not a fork. It's upstream conformant. We're always running integration tests with different community tooling. And there's seamless integrations that work with EKS out of the box. So logging integrations with tools like CloudWatch, ingress integrations with application load balancer, security integrations with IAM, and we'll continue to add more of those. So really with EKS, you get to take advantage of all the operational best practices that we've learned over the last couple of years of running millions of clusters in production. So we're continuously improving our deployments, our monitoring, our alerting. So you just spin up a cluster, you get a Kubernetes endpoint, and you really don't have to worry about anything else. So after we launched EKS with that managed control plane, a lot of you came back to us and said, well, what about the data plane? And the problem we heard from you is that in order to add compute capacity to your cluster, it takes a lot of separate commands and tools to launch EC2 instances, auto-scaling groups, adding nodes to your cluster based on traffic you're receiving. And in addition to just adding capacity, there's also a problem with manually updating nodes to apply security fixes, new Kubernetes versions. And the ask we heard was, this is something EKS should automate as well. And this was always phase 2 part of the plan. And so the first feature we launched was at, I believe, KubeCon last year, was EKS Managed Node Groups. And what Managed Node Groups does is now with a single EKS API command, will launch an auto-scaling group with EC2 instances configured with best practices, so you don't have to manage any of that on your own. There's also different Kubernetes API functions built in, so adding labels directly to a node is something you can do. It's easy to keep your worker nodes up to date as we continuously release new AMIs with the latest bug fixes, security patches. And I think one of the big benefits you get with managed node groups is the sophisticated upgrade logic that we've built in. So when you call the update API, we're going to safely cordon and drain old nodes to move them onto new ones with the least amount of disruption. Some of the features we launched this year with managed node groups, we added support for EC2 launch templates. So you can now customize your managed node groups, things like user data, EBS volume encryption, adding tags to instances. You even support custom AMI, so you can bring your own operating system. And then one of the features we're launching at this year's reInvent is integration with EC2 Spot. So you can launch an EKS managed node group and take advantage of the cost savings with best practice Spot configurations. So that was option one for phase 2 of the managed data plane. Phase 2, which we launched at last year's reInvent, was EKS on Fargate. And this is even a step further if you want an even more hands-off experience. There's no EC2 instances in your account. You don't have to worry about that at all. All you do is add your resource, your CPU memory requests in your pod spec, submit it to your cluster, and then you let Fargate go and handle the capacity provisioning. So it's a seamless workflow with your existing Kubernetes deployments, and you can let Fargate handle all of the patching, the scaling. It's not something you have to worry about. The other nice benefit you get with Fargate is that each pod runs in its own isolated compute environment, not shared with any other pods. So if you have a particularly security-conscious workload, Fargate may be a good candidate. And then we have native integrations with other AWS services. So storage, we integrate with EFS. Logging is an integration we're actually launching at reInvent this year. So using FireLens and FluentBit to send logs to CloudWatch, Elasticsearch, and other services. And then security integrations with IAM. And I think it's important to note that you can mix and match. Some workloads may make sense for running on Fargate. Other ones may make sense just running on EC2 instances. And you can mix and match within your cluster, and you run your workloads on the right managed data plane option that works for you. And that leads us to phase 3, which again was always part of the plan. And the last major problem we've heard from customers with getting up and running with EKS is that it's one thing to have a control plane and the data plane with compute capacity, but for any true production workload, you're going to have some prerequisite operational software to run in your cluster before you can actually run your applications. And these can include add-ons for logging, storage, networking, auto-scaling. And curating and maintaining that list of software is, again, just that undifferentiated heavy lifting. Customers don't want to have to do it. And so phase 3 of this is what we're calling EKS Addons. And this is bringing management of those operational add-ons into the EKS API itself. So this will allow you to install certain add-ons as part of the cluster creation that are managed by Amazon EKS. And this completes the picture, which is why we're saying phase 3 and the end of the initial story for EKS, because now you can upgrade both the control plane, worker nodes, and add-ons directly through the EKS API itself. All add-ons are going to include the latest security patches and be tested by EKS for compatibility. You can use IAM roles for service accounts to give fine-grained IAM permissions, so the add-ons won't have any more permissions than they need. You can configure certain parameters of each add-on. And then at reInvent, we're launching an add-ons compatibility with the VPC CNI plugin, but we have a long roadmap of additional add-ons that we're going to be bringing online into 2021. So kube proxy core DNS, and then things like the load balancer controller for ingress, cluster autoscaler for scaling, FluentBit for logging, and then GitOps in the future. So adding add-ons like Flux, for example, to give you an easy way to sync your application deployments to your cluster. And that completes that 3-phase journey that we always saw with EKS, where you can spin up a cluster, get a control plane, get compute capacity, have the add-ons ready to go, and then it's as simple as that. You can just start deploying your applications and let EKS handle all of the infrastructure and add-on management. Before I hand it over to Verizon, I did want to talk about some of the tools that we've built and maintained to make getting started easier. The first one I want to point out is EKS Cuddle, which is the official command line tool for EKS. It's developed by our friends at Weaveworks, and we work very closely with them on making sure that any new EKS features are supported in EKS Cuddle. With EKS Cuddle, it's as simple as that command shown on the bottom of the screen. You run the create cluster command, and you'll get a VPC, IAM roles, a cluster with node groups or Fargate capacity configured with best practices, and you don't have to. It's the easy button to create a cluster, and it includes utility commands, for example, to do things like applying IAM roles to particular add-ons. Utils command to keep add-ons up to date for the ones that weren't originally as part of EKS add-ons. And then another important feature of EKS Cuddle is that it is GitOps enabled. So you can define your infrastructure in Git is the source of truth, and then use EKS Cuddle as an easy way to sync that application source of truth into your cluster. And there's certain quick start profiles that are included that help you get up and running. For example, if you want to run a cluster for machine learning workloads, you can use a machine learning quick start profile to get you a cluster that's ready to use. And then this one we're very excited about, the cloud development kit for Kubernetes, which we open sourced earlier this year. The problem that this project really is addressing is, with every Kubernetes deployment, you typically have a bunch of carefully maintained YAML files that you're using. And as your applications evolve, these YAML files need to evolve. You're typically sending YAML snippets and boilerplate code over chat to different teams. And it's hard to keep up and maintain that as your applications and your teams grow. And so with the CDK for Kubernetes, is taking the same architecture that the customers like for the CDK for AWS and moving that to the Kubernetes API. So you can define your Kubernetes applications using familiar programming languages. Python and TypeScript are supported today, and there's additional languages coming online. It's easy to generate well-formatted YAML every time. And I think one of the powerful parts is you can create and share reusable components. So you could have your cluster administrator team define a library that every development team uses for its deployments and ensure that there's consistency and standards throughout your organization on how to deploy applications. CDK runs locally, and it generates YAML you can deploy to clusters anywhere. It can be an on-premise cluster or in any cloud. So I'd say check out this project. This is definitely one that helps you get up and running without having to be an expert in YAML and figuring out the exact syntax that you need to deploy applications. And with that, I'd like to hand it over to Verizon. This was, I gave a general overview of how to get up and running with Amazon EKS, but Verizon's going to talk about its own specific journey of getting started on EKS and how they're running at scale.
Thanks, Mike, for giving a detailed overview on EKS. Hello, everyone. Hope you all doing good. This is Sudhir, working as Senior Manager at Verizon. Let me take a moment to tell who we are. Verizon, we create the network that moves the world forward. Verizon is the first to launch 5G in the world. Verizon 5G nationwide today is available over 200 million customers. Verizon network and platform supports device launches all through the year and during a retail season, where customers try to purchase their phones for themselves or their friends and families. So today I am going to talk about a journey where we migrated a platform which supports these device launches from monolithic to microservices. Vamshi Kalluri, my colleague, will be joining me in this presentation. I would like to take a moment to appreciate AWS support during this journey. So for any migration, you need a good architecture and planning. So for us also, we team at Verizon couple of years back when we decide to modernize and migrate this monolithic stack to microservices. So we came up with a good architecture, which is we branded as North Star, so which we're going to cover. So North Star architecture, which as it means it covers the current Verizon needs and also the future Verizon needs, which Verizon is going to use it to launch lot of 5G products. For Verizon, the customer launches Verizon sites and apps using a different channels, be desktop, mobile app, or they can call a customer care, or they can go to a Verizon store. So far, all the stacks that we have were so centric to these channels, and they were also all on monolithic. So with the North Star, we decide to modernize these stacks, and also we want to make the customer journey, these stacks combined together to make a service which are also centric to customer instead of channel specific. So what does it mean is a customer can start his journey on one channel and they can move to a different channel. He can still continue his transaction from wherever he left off. So Verizon, a customer can start ordering a phone on desktop and he can move to a mobile app and he can still continue his transaction. So now we have architecture. So we need to pick a platform where we can deploy these agile services. So that's when we choose EKS as a platform. EKS natively provides a lot of capabilities which helps to deploy these services. So EKS self-healing, scalability, and service discovery, service load balancing, all those things really helps to orchestrate and operate these services. So the self-healing, that feature really helps the AI operations which everybody looking towards. So now we have the architecture, we have the services, and we have the platform. So how we want to migrate from monolithic to microservices, that's we're going to cover in next slide. So for migration, we use the Canary solution. In Canary solution, you're going to have two versions of platform and you migrate from one version to other version in a phased approach instead of doing in a flash cut. So like here mentioned in the slide, the blue environment, the below one is the monolithic stack where you have front-end services and the back-end services, and the green one is the new modernized stack where we have deployed the microservice on EKS. So like any other IT organization, you have front-end services and the back-end services, and they are separated using API gateway, and the front-end services are front-ended with CDN, which is edgecast here. So Verizon customer will either accessing desktop or a mobile app will be routed to this edgecast, and that's when it will be delegated to front-end services, and they will call the back-end services to get the whatever the required data, whatever it is. So now to migrate from monolithic stack to microservices, so we start inserting the Canary header right at the edgecast. So as you can see here, the blue environment was the legacy and the green environment was the new microservice which are deployed on EKS. So we start inserting the header and route the traffic to, at the edgecast we put a rule to route the traffic to new environment which is running on EKS. So we first enable it for the pilot users, and then we slowly start enabling for a few regions, few states, and then we started with 5%, 20%, like that we went up to 100%. So it's a low risk approach. You can easily roll back. If there is an issue, you can just stop inserting the header and then you move back to the previous version. So not only for the migrations, we use this for the weekly releases where we first deploy our code into a Canary environment and we'll enable it for the pilot users to validate. And then once the validation is done, once the certification is done, the same code will be pushed to production environment. So this way you are having a low risk when you roll out a version into your platform. So like any migration, our migration also was not smooth. So we had some challenges, so which we're going to discuss in the next slide. So this slide covers high level what are the challenges we had during our migrations. To migrate monolithic service to a microservices, it's not an easy task. It's a big cultural shift in your environment. So your developer, support guys, everybody has to upskill. So they have to go to a lot of trainings. So developer has to go to a lot of Docker trainings. Support guys has to go through AWS, EKS trainings to get up to speed on this journey. And also you cannot do this migration overnight. So you need a good planning, a good architecture, so that you can migrate your service from monolith to microservices. It took us around a year to do this migration, but every migration will be a different. But yeah, so you need to have a good planning to do the migration, and you cannot lift and shift your monolithic stack to a microservice. You need to first break them into microservices, and also you need to tune it well so that it fits into a Docker container, and you need to tune at the pod level. Pod is the where you deploy your code into a container and you run in a virtual environment. Then you need to, we had challenge some scaling. So we had challenges with control plane scaling, data plane scaling. So what tunings we did to overcome these challenges, we're going to explain in the subsequent slides. To again, we learned it a hard way. We need to do a good capacity planning on your network. You need to do a right size your subnets so that you don't run out of IPs. Also, when you break a monolithic stack into microservices, there will be lot of chattering going on between your services. That's going to put a lot of stress on your network. So you need to tune your network load balancers, your DNS very well so that they scale for your needs. And also you need to do a lot of testing to do these tunings. Then the last but not the least, logging. When you break your monolithic to microservices, you're going to have a lot of services talking to each other and they're going to spit a lot of logs. It's going to be very difficult to trace a particular transaction. So you need to have a centralized log repository, and also your log shipping platform has to be scalable without dropping any logs. And also you need to have some correlation ID to track them. So any issue you can stitch between all the transaction, all the microservices, so that you can easily figure out where the issue is. So these are the high level challenges we had for our migration. So my colleague Vamshi will take over from here. So he will cover what are the tunings we did to overcome these challenges. Thanks again for giving this opportunity. My colleague Vamshi will take over from here. Over to Vamshi.
Hello everyone, hope you're all doing good. My name is Vamsi Kalluri and I'm a distinguished member of technical staff at Verizon. Thank you Sudhir for giving the excellent overview of our core architecture that Verizon has chosen for our new journey to the mono microservices platform, and also the challenges that we have encountered as part of it. Today, I would like to take the opportunity of covering few of the platform tunings that we have adopted during our journey. To start off with the cluster. The cluster CI/CD is a key for your platform, auto provisioning your cluster, applications, services, and any updates to the EKS cluster. So we have to automate a lot of things as part of the platform setup, to start off right from scratch from the cluster builds, to make sure they are optimized and customized to our security standards that Verizon had. We did have to scale up our repositories, and also as part of our application rewrites, we adopted most of the K8's native services like the config map, secrets, etc. For the cluster scaling and performance, we have used the cluster over provisioner to make sure that our cluster is pre-provisioned to at least 20% to handle the additional workloads that we expect during our peak traffic hours or device launches. And we also made sure the nodes are highly scalable and the AWS managed control planes are upsized accordingly to meet our requirements. Also, we had to tune few of the configurations for the actuator, which is the health check, as part of the self-heal. With the new microservices architecture, you would definitely see a lot of inter-service calls that would be happening. So we have to fine-tune few things to move them to use IPVS, the IP virtual server, instead of the IP tables, and also update the routing to round robin. We also applied the pod anti-affinity rules for deployments for a better performance. Next, to the network tunings. As part of the network tuning, we had to right size and spin up a new dedicated subnets to avoid for usage to avoid the IP exhaustion in our VPC. We also did optimize and customized our container network interface, which is nothing but the CNI, to use the secondary CIDR blocks for the ports. Many other optimizations were done around DNS to use node local DNS instead of the core DNS for the better distribution of DNS queries. Use UDP, which is the user datagram protocol, a connectionless protocol for faster resolution of the naming queries instead of the TCP. And also we did prefetch and cache the queries based on our requirements. The load balancer tunings. Few of the tunings that we have done from a load balancer is like we pre-warm the ALB LCU load balancer capacity units to handle additional workloads instead of relying on the auto scale. We did there were annotations changed to support the IP and optimizations for registration and deregistration in the ALB ingress controller. Next. Coming to tuning on the logging and monitoring. Logging and monitoring is a critical function to make sure that your platform stays healthy, and it would also provide any kind of insights and metrics that may require proactive action. For the logging, we chose FluentBit as our log processor and shipper, and many optimizations were performed on the FluentBit config to handle the real-time streaming requirements which we had for our applications. Several other tunings were also done as part from a Elasticsearch cluster service standpoint. Monitoring. When it comes to monitoring, control plane provides audit and diagnostic logs directly to the CloudWatch. For the core EKS monitoring, infrastructure monitoring, we did use CloudTrail, and we used New Relic as the APM for our services monitoring and alerting. We did have a centralized consolidated dashboard on Grafana to provide us a one-stop view of the complete monitoring from your cluster and the services. So coming to the next one. So far we have covered the platform tuning on the platform tuning. Now it comes to the actual pods and the nodes tuning, which are really critical for your application. Kubernetes provides different levels of quality of service to pods depending on what they could request and what limits are set for them. For each resource, containers specify a request, which is the amount of the resource on that system will guarantee to the container, and the limit, which is the maximum amount that the system will allow the container to use. So scheduling is based on the request and not the limits. As you can see, these are the available quality of services that you could opt for your pods based on the workload requirements. We chose to use the guaranteed quality of service for our pods for better stability and based on our application workloads. Mainly we use this to remove the noisy neighbor scenario. We also pre-provisioned our nodes to handle additional capacity to handle the flash traffic or flash traffic that we usually encounter during any kind of a device launches or retail seasons. We also use the HPA, horizontal pod autoscaler. So basically this would based on your memory consumption or any kind of a CPU consumption, whatever metrics that you set, it would change the Kubernetes workload and the pods. It would increase or decrease the pods accordingly. And I would really thank AWS, who have helped us a lot in many of the accomplishing many of the tunings to handle our workloads. In conclusion, coming to the next one. In conclusion, these are few things that we Verizon have adopted and would recommend you to consider when you are towards your journey from a monolithic architecture to the microservices architecture. Do upskill your teams on containers and KX, which is the prime first and foremost for your success. It would be a major cultural shift for the team to transition from a monolithic standpoint to the microservices. Do optimize and break down the applications based on the business logic, which would be to rather than making it very bulky. Security should be in your DNA. So when you please make sure you bake the security aspects right from the way you are building your application containers, applications, and also build and runtimes, to make sure you have all the automation to deploy your clusters as well as the applications, modify your clusters accordingly, tune the cluster to fit your ecosystem and workloads. Good monitoring and logging would definitely help you reduce the work costs that you would be costs, as well as it would have you a better visibility and to any issues, which would in turn help you to provide a better and reliable customer experience. With that all said, thank you again for giving us an opportunity to share the details about Verizon's journey and how it operates on EKS. Thank you.